Hey everyone, welcome to the SIG Node meeting on October 7th, 2025. First up on the agenda, we have Yuan Wang. Are you here? Actually not seeing anyone with that name. This was from last week, so maybe this item we won't talk about. Next up then we have Sotiris.
Yeah, I think we took this online. So already I have review from this CAP. The purpose was to announce that we are moving ahead and we are trying to put this on 135. So there is one open question, but the discussion is continuing now in the CAP itself. So I don't have something more to say. Thanks for the support. I already have lots of review from 4 contributors. So all fine from my side.
Awesome, thank you. I don't know if Chun-Chi is here. I think they're in APAC and didn't have time to talk through this last couple of weeks. Okay, so then on to Praveen.
Hey, hi. I'm happy to go at the end. I plan to take around 15 minutes or so. I want to make sure I don't block anyone.
Cool, thank you. Yeah, we'll do that. All right, Kevin.
Yeah, just I drafted a CAP around the kind of taking the next step for C group V1 removal. I posted an issue and there is a CAP. The general plan is to set the kubelet flag fail C groups V1 to true and force people to opt back into C groups and at least have a more formal stance that we are deprecating C groups V1. I guess if I have 5 minutes, but if anyone has any concerns, probably the best thing is to put it on the CAP.
So to clarify, Kevin, I was reading through the post on the forum. So we are saying it's deprecated, but not removing the code yet. That will be decided later based on how distributions support it and for how long, right?
Yeah, we wanted to kind of do phase 1. I guess we're technically calling it a beta, but that will be deprecation. And then we call out that we will decide on the removal date at a future time. But I think the ecosystem, we will probably want more time to figure out from the ecosystem. I mean, I think the general trend is C groups V1 is getting deprecated in a lot of places. The kernel has not yet made a stance on that, but System D has made a pretty strong stance on it. But
okay, what is our stance on bug fixes? So features definitely we won't be adding to V1, but with this, are we saying fixing bugs are we fixing bugs, not fixing bugs, or a best effort?
I think we still technically, so it's probably not much of a difference between maintenance mode, to be honest, but like we still would fix bugs because I think we still, at least that's I guess that's kind of the difference there. I'm not actually sure for like when we deprecate something in Kubernetes, does it mean we no longer do any fixes for it? Because we committed to at least testing and verifying, so there might be like regressions we cause, might be things we still carry, but I don't know if we would respond to bug fixes and C groups V1 that are outside of that. Kind of a good point.
It's like Sergey and Don. So.
Yeah, I just wanted to clarify that with deprecation, we also start in a clock. So our deprecation policy requires us to announce it at least 2 releases ahead of time. So at least we start in a clock and we enable ourselves to remove this code in 138 if it will be already completely migrated by majority of customers. And I also wanted to mention that we will see very few contributors who are interested in C group V1 because majority of places are already deprecated, and most of use will be on some on a different kernels, like distros that we not necessarily test in upstream. So we will have potentially we have a lot of test failures and test lanes broken with very little interest to fix them, and it will be another signal for us whether people interested in cgroup v1 support or not.
I just want to say we need allowance as soon as possible. I would rather extend it like a period of time for people to spend the time to migrate and find the issue and all those things. But we need to announce that trend as early as possible. From my perspective, I think from the community, right? So our community, we definitely want to deprecate and then we reduce the complexity for our maintenance and the code base. But the only my problem it is like, for example, like a user, like especially for the on-prem user, like OpenShift on-prem user also. So how many they are still couldn't migrate? We don't know. If we don't announce, people just basically just don't know those kind of things until just like the last time for the Docker shim deprecation, because from day one we told people, and we also handle most of the things, but people just last minute until we announced they got panic. And let's announce as soon as possible.
Yeah, I agree. I think makes sense.
Then we just need people push us to, we can extend it, right? So later, but just at least no new feature added. Any new feature added and into the SIG v1. Only thing we can promise just during that period of time, we don't introduce new regression because we keep test for longer time. That's all.
Yeah, and once we approve the cap, let's merge the disabled true as soon as possible, so we can have people adapting it and telling us what's wrong, if anything is wrong.
Yeah, sounds good. Thanks, everyone.
Great. Thank you, Kevin. Yeah, good idea to get it started. All right. Next up, we have Priyanka.
Yeah. Hey, folks. I was helping with this KEP 3085 board ready to start container condition, and Sergey, you are aware about the bug report we received. So I tried to create a simple reproducer just to try and recreate the error that the person who created the bug report both in KK. Now I just saw an issue in Slack. I am able to reproduce it. I wanted to understand because Sergey, you commented on the KEP PR that this was not what the KEP design actually considered. So is this something, from what I understand, is the current sync port flow, even after the port sandbox plus networking setup is ready, it does not update the port ready to start containers condition until the image is pulled, like, so until the entire flow is finished. So can we update port sync port at right immediately after networking is done and port sandbox is done? Is that something that we can consider, or what could be a potential solution at this point? Yeah.
When you say at
Just
this
want to
point, is it because of a release, or like what is the problem? Do we have a lot of adoption of current behavior and we don't want to change it? Like what is the problem?
Yeah, so I am not aware of the adoption. I think that is also something that's already discussed on the KEP issue as well as KEP PR. But one thing I see is from the end-to-end test plan, we actually are testing scenarios like we do not want this condition to be true until, let's say, volume is created, which is also much later after the sandbox and networking setup is done in this sync port flow. So maybe there'll be like a little bit changes in the end-to-end test plan also. But Kevin, do you want to add? I've just picked up this kept this cycle, so that's my understanding so far. But yeah, I don't think there is much of changes required. Just feels like we did not come across this scenario
As far as I
before.
remember, the story, the history of this cap is we started with somebody wanted to get a sense when CNI is completed, but then we retargeted it and changed the name of a condition to containers are ready to start, and volumes indicating that containers are ready to start. So this is totally aligned with what the design was. I'm surprised that we also require the user container to be downloaded. This seems to be out of place. So I think that may be a bug. But I mean, if we can prove otherwise and say it's not a bug or like maybe some reproducer is wrong, then we can continue with GA of this feature. If not, then we need to fix it first. And then according to GA criteria, we want to have no bugs for a period of time and then we can GA.
Yeah.
So I thought we were saying that when the containers are pulling, it's still saying ready to start containers is false, and it doesn't switch to until they're pulled. So to me, that sounds
Correct.
like, Sergey, what you're saying is that's working as intended.
I thought that we only needed sandbox to be fully prepared. But I mean, containers are not pulled in parallel. So are we only waiting for first container? That may be quite controversial. I thought it shouldn't be included, like image pool. But if it's by design, then yeah, I'm happy to be proven wrong.
Kind of weird, like because we pull images and then start containers sequentially. So like, maybe the name of it, the condition is a little bit off, but I think like intuitively what you're saying, Priyanka, makes sense to me. Like changing sync pod so that we update the pod status so that it's ready to start containers after the network is up before we start pulling images, but then the images are going to start soon. Like that is what the condition sounds like to me. But I do agree that the timing might be a little bit weird because like it's not ready to start every container right when that condition starts. It's just ready to start the first one. It'll go sequentially through. But because we're not pre-pulling the images before starting any containers, I think that's the best that we have. So I like naively, without really fully understanding the context of why it was done this way in the first place, it sounds like it is a bug to me, and it does sound like updating the status after the network is up sounds right to me.
Network and CSI.
Yeah, exactly. Network and CSI.
Okay. I tried a potential solution. I have that in the just at the bottom, but maybe I'll try creating a PR for that and also add a comment about that in the KEP itself. Sergey, would that help move the KEP updating PR for this cycle?
I think if this is a bug, this will block it from going GA, at least for another release. So I think that's probably what I would investigate, and then like maybe look at like whatever we decide we'd want an end-to-end test verifying this, and then we can kind of reevaluate the GA of this one. But I would focus on that without.
Okay, I'll try creating PRs to fix the behavior then. Yeah, thank you.
Yeah, and another thing that we may need to update is whether DRA needs to be included in this condition as well, because DRA can be per sandbox, and we may want to prepare the devices as well. But I'm not sure if it was already handled. I didn't read the cap recently.
I don't think we ever included DRA in scope for this. This one came out in 125. So I don't think we adopted DRA since then.
Yeah, because DRA has a little bit of difference. It has like global devices potentially, so we may need to include them as well.
Okay, I'll take a note. Yeah, thank you.
Great.
Thank you, everyone.
Thank you, Priyanka. All right. Next up, we've got Maria.
Hello. This one should be quick, but it's just kind of getting everyone up to speed on KEP 4205, which is exposing PSI metrics. I know you mentioned that aiming for GA in 1.35 is a little fast. And so I talked to Howie, who's helping me with this, and he said aiming for GA 136 is a good idea. But in the meantime, gathering real world user use case information can be really good. So I announced it in the Slack that there's a survey that I'm putting together to get information on that. And so you can see that on the doc as well. I linked it. And I know there was mention by Kevin Hannon of there's still some issues in C Group V2, but I recently saw a comment that looks promising. So maybe it should be on track for 1.36. That's all.
But this one, right? Like, is this the issue where I think there were some performance problems in the kernel when this was enabled? Like there was an overhead. So are we still tracking that? Is that fixed? If we enable this, are we taking that on because it's negligible? Do we
Well, I
know?
think, and to add a little bit of clarity, I'm pretty sure that was also mostly with real-time kernels. I'm not sure. And I think there is a light performance hit all the time because we're just like the kernel's collecting more information. But I think it was really mostly noticeable in real-time kernels.
Okay, so I think if we take this to GA, we should probably have a knob where real-time kernel can turn it off if they so desire.
Yeah, I mean, I think, yeah, I agree. Remind me with the way that it's currently working, if PSI is turned off in the kernel, we're not attempting to collect any of these metrics in Kubernetes, right? Like if the controller isn't enabled, then it's like a no op basically.
It's reading from the C advisor. I think it's on the kubelet level, we don't have a knob. So if the underlying C advisor is emitting nothing, it will still be reading. It's possible to add a knob, but I haven't checked if there's like a performance overhead if there's nothing to read from the C advisor level.
Yeah, I think so. I think just verifying, like in the case that the PSI is disabled on kernel level, that C advisor is not collecting those metrics. I think would be the way. Then the kubelet wouldn't have to have any configuration. It would just be a kernel level field, and then C advisor would opaquely figure out, okay, is PSI on? If so, I'm going to collect the metrics. If not, I'll leave them be. That would be my recommendation. So maybe we can do that investigation in the 135 time frame.
Yeah, that makes sense. Yeah, in this kubelet level, I think it's still like reading the. If the advisor is emitting nothing, the kubelet may still be trying to read from that field. So it's possible to add an additional knob to like even get rid of that overhead. We can add it if it's wanted.
Yeah, I'm like currently the list of like stats and metrics that C advisor gathers is fully like just hard coded, and I think that we could have changed that along. I mean, we could change it at any point. We're also like, there is a world where we move to CRI stats, even potentially a beta this release, which would sort of like even preempt that need, because then it's fully up to the CRI implementation what metrics are being reported. So I would personally vote that we just like make sure that C advisor is not needlessly collecting a bunch of zeros if PSI is not enabled at all. And if that's the case, then I don't think we need to make the knobs in the kubelet any fancier, because we are actually getting pretty close to CRI stats, where it could be actually toggled in this CRI implementation. Don?
For this feature, I remember in some meeting, I forgot which meeting, I asked, do we have the stress test? Do we have like the overload head test? And did we do those kind of things? Is there any potential problem? And
For the metric collection, we did some performance tests on the overhead. I think you might be talking about using CSI to take action at the node level for things like eviction or taint on that, it's treated as a separate cap right now. That part we haven't gathered data yet.
That is the separate one. That's the after the monitoring data collected, right? So, and my question is more like from this overhead, additional overhead of potential, because this additional overhead potential of the performance downgrade. Have we ever done the enable this one without this one? And what's the behavior on the stress test?
Yeah, we do have a performance test to get some overhead data, but I can share the results in the agenda and we can review it.
So we did create of the manually create of the stress, right? So environment.
Yes.
Okay, cool. Yeah, thank you. Please share with me. Yeah.
Awesome. Did anyone have any other items here? Okay, cool. Oh, yes, Felipe?
Hi guys. Sorry, I've been a bit away. But I am very interested in place pod vertical scaling, especially in relaxing immutability of pod template resource. Kevin, do you need a help and task to do?
Sorry, no, I think that's not really in this SIG. Maybe we can bring it up on the. Sorry, this is the pod mutable. Yeah, it's more of SIG apps. You can bring that up on the working group batch. I think that's more appropriate for an answer there.
Nice. No problem. Thank you.
Yeah, but thanks for asking.
Cool, thank you. All right, next up on the list we have AJ.
Yay. Thanks so much. Can you please share me screen so I could share my screen? Okay, permissions. I think I got the, yeah, I got it. So just a quick feedback, node readiness gates has been discussed last quarter. There is a KEP open that is still up for alpha for discussion for 1.35. We got API feedback last quarter that like we should get more community feedback on this to define the shape of the API. To enable that, like I built this as a like standalone controller outside of Kubernetes, like out of tree. I want to show a quick demo of that on how this could like perform in action, and I think that like we maybe would be able to continue the conversation after. Let me quickly share my screen. So I captured a video of like setting up with kind cluster and like installing and all of that. I think like that's maybe of lesser interest to this group. I just would try to show here. This is a kind cluster. Please let me know if the screen is not visible, if the terminal is not. It's not clear. But here we have a kind cluster. At the left, I have 3 nodes. Worker, there is one platform node categorized as a separate node which runs the node readiness controller, and I have like a deployment of Nginx that's running on every node. So the goal here is to scale this to 100 nodes. I'm using Quark, which is a 6 scheduler sponsored project for simulating nodes to save us time. It would just create a node object and the kind cluster would see that as a real node, but everything else like that, the communication, condition update and everything would just like happen in a real world scenario. Just to scale this up, I want to show, and yeah, show 100 nodes. At the left, I see that like the goals are being noted up, and immediately the readiness controller added a taint. If you see this readiness.gates.io, network ready is the taint that watches for Calico readiness. Here in this case, like this condition is not present, so the taint is being added on all of the created nodes. And I would try to now emulate the condition being patched. So when a condition is updated, the taint is to be removed by the node readiness controller. Let me update the Calico condition ready. Let me also show this. This just sends this calico ready as true, and just like a message, this would be similar to so all of these conditions are updated for the nodes, and once the node condition is updated, the taints are being immediately right away removed by the node readiness controller. Now here at the base, I have this. Oops, did I? I'm checking whether there is any satisfied node, unsatisfied node pending. So all of these are satisfied node. So the 100 nodes are all updated. The taints are removed. Now what I'm going to do is like try to see. So this is conditionally, continuously monitored by the node readiness controller. Now I'm going to flip a condition of any one of the node, 1 or 2 nodes. So Quark node 0 is updated with ready condition as false, and we see that is equal to false is not shown here because I didn't know how to neatly show this here, but the condition is now false. We could get it from kubectl get node Quark node 0 and oops, because I didn't do this. Yeah, here you see that like it's set to false, and the taint is immediately added. Now we'll try to do it one more condition, and the 11 would be added. I'm flipping it again to show that the removal is also effective immediate. It's flipping to true, and the taint is removed. So this is like the concept controller I have developed. My ask here is to, before we get into the ask, are there any conditions? Are there any questions over here in the demo?
So the conditions are pre-declared, right? So you have a constant set of conditions, not the regex or anything.
Right now, it is constant set of conditions. Are you asking about the conditions being monitored? This is what I showed you. I didn't show this. Kubectl get, I think I can show it here. So this is the okay, this would have like really large because 100 nodes are monitored. Let me show the
So is it kind of CRD where it's all written down?
yeah, it's on a it's a CRD. Let me show you the sorry, I've been a bit too many things here.
It's okay. It's really hard to find something on the spot, so you can just answer.
I could show this. Oops. Oops. I'll show you at the GitHub repo. I think it's easier to do that way. I'm switching my this is how the condition will look like. It will check for a specific condition. In my case, I just have like one conditions type as calico ready, and it will match to the taint that was added, network readiness.k8io and network ready. And I also defined a 2 enforcement mode. Right now, what I showed is a continuous mode where it will look for if there is change in condition, it will immediately swap back the taint as well, giving a continuous guardrail on the on the role. So this is how it is work based on a CRD. However, for the proposal here is based on having this as an API. So it's API discussion still need to be continued. I want to bring this to community adoption and see what the feedback is on, so that we'll be able to better define, or if you need like more adjustment on the course of this solution in tree. So the ask here is two things, like if you have any feedbacks, please pass on to me. And primarily, I want this to be a SIG sponsored repository, so that like it could be more acceptable for community and easily be adapted, and we'd get more feedback that can help us define the structure or the solution in Kubernetes. Please let me know if there is any feedback, and I'd be happy to discuss more.
Great, thank you, AJ. I like this. I like the direction of this, using the built-in mechanisms of taints and toleration. So great work. Yeah. If we don't have any direct items to talk about there, then we can circle back to Praveen.
Yeah. Can you give me permission to share the screen?
Yes. There you go.
Okay. So my screen is visible, right? Okay. Cool. So hey everyone. So I wanted to get some feedback on the proposal that we are working on, and this is to make like the core resources that are like scheduled, also like managed through DRA, work better with the existing like Kubernetes, like kube scheduler and kubelet and so on. So this is like a enhancement issue. I think like we are targeting 136 for this, because there are a lot of things to look into, and but just wanted to get the discussion started and get some feedback. So uh currently, like basically the core problem is this: like now we have a CPU DRA driver which is used for like assigning exclusive CPUs through resource claim. And the core problem is like now I mean, since we also have like CPU that is managed through uh like natively in kube scheduler, so basically like the node publishes the amount of CPUs that it has through node allocatable, and like the kube scheduler uses that to schedule the pods. Now we have like another competing way to publish CPU through resource slice. And also like on the consumption side, we have two ways. Like one is through the pod spec, where we can request for like CPUs, and the other one is through the resource claim, where again we can request for exclusive CPUs. And in the current DRA driver, we are only managing like exclusive CPUs, and by disabling kubelet, we make sure like both kubelet and the DRA driver are not trying to set the same like C group settings on the node. So like the problem that we are trying to solve is like, since these are these are managed like independently in the kube scheduler, so the standard resources are managed through like the node resources plugin. It looks at only node allocatable and pod request. There is another like plugin on the scheduler, which is the dynamic resources plugin, which looks at like resource claims and resource slice to like make the allocation decision. And the problem becomes like one is on the scheduler side, we could have resource over subscription. So basically a pod can be scheduled on the node, like because the dynamic resources plugin thinks that it has enough CPUs, but it is taken up by like shared CPUs as requested through pod spec. And the other problem is on the node side, like where kubelet, currently we compute things like QoS class, which is basically only based on like pod request. and now that like we are also requesting through resource claim, that is not correctly accounted for. So there is a probability, or like it is very possible that like a guaranteed pod can be categorized as like a best effort pod, and that has a lot of downstream effects, like in the way that the C group is set up by kubelet, and like eviction and preemption decisions and scores, and like incorrect score and so on. So in the current CPU DRA driver, like the workaround that we rely on is like any request that is made through resource claim, we also like duplicate that request through standard resources, so that like the accounting part on the cube scheduler side works correctly, and also like the QoS class and so on the kubelet also is computed correctly. This is just like a temporary workaround, I would say, because one, like a couple of drawbacks that I could think of is like, one, it is very fragile in that like we rely on the user to make sure all of these settings are duplicated correctly. And as we have like a lot like more resource claim within the pod and more complicated use cases, like multiple containers within the pod sharing the same resource claim, it would become very difficult to set the standard request correctly. And the other problem is like with advanced DRA features, like one of the features that like the feature request that we currently have is like that some workload would want the ability to specify like a prioritized list of devices that they prefer. So I've given one example here, like where a resource claim would be something like, give me one GPU if it is available, but if it is not, give me 8 CPUs. And in this case, like the scheduler will first check for GPU, and if it is not available, it will look for CPUs. And in such cases, it becomes like impossible to basically at the pod creation time set the standard request correctly to ensure like all of these accounting and enforcement on the node works. So yeah, this is the problem statement at a high level. And through this proposal, like basically we are evaluating a couple of approaches to try and solve this. So one of them is like the mixed ownership model, where on the DRA side we continue to manage like only guaranteed requests and rely on kubelet managing the shared request. And yeah, like this is called mixed ownership model. And the other model that like we that has been discussed in this doc is like this unified approach, where like uh if we have a way to say from the node, like a node flag which says like CPU is exclusively managed through DRA or exclusively managed through kubelet, we wouldn't run into this conflict. So like the rest of the proposal like talks mostly about mixed ownership model, because with the unified approach there are a few concerns like currently. Like one of them is it adds like a high initial cost of implementing all of the mechanisms that we have in kubelet also in the DRA driver, so that we can manage like shared and exclusive resources correctly, along with things like preemption, eviction, QoS, and so on. And also backward compatibility is one of the other challenge, where we want to like continue to be able to use like existing workload spec uh like yeah, like even with the DRA driver. And like this unified approach would also mean that like all of the CPU requests would have to happen through resource claim, and that would like result in a lot of API objects, and there are like like some scalability concerns on the scheduler side on being able to handle like all of these like requests through resource claims. So yeah, like rest of the proposal is mostly like targeting the mixed approach model. So yeah, so in this approach, like basically the proposal is to make a couple of API changes. One is on the device class spec on the DRA side, where we say like if a resource is if a pod has a resource claim which is also backed by core resource, we specify in the device class explicitly to say that like this core resource name that is used here is CPU, so that like the kube scheduler correctly knows like when to delegate the resource accounting to the dynamic resources plugin, and when to do the resource accounting in the node resources plugin. So this is one way to explicitly specify it. The other API change is on the pod side, like where when a pod is being like is evaluated, or resource claim is evaluated and the pod is bound to a node, we explicitly add this in the pod status, like which would contain information about like the quantity of resource that is allocated to the resource claim, and like other basically the name of the resource and the claim itself and so on. So this becomes like a feedback mechanism to like the kube scheduler for accounting CPU from two sources, like the standard source and also the DRA source, and calculate the amount of available CPU on the node correctly. And the second use for this is on the kubelet, along with looking at the pod spec request for CPU. We would also need to look at like the DRA based allocation to basically decide like what is the appropriate QoS class, and also use this for like setting creating the C group hierarchy and eviction and preemption priorities and so on. So yeah, I can pause here like for any questions, or I can get I can go a little bit more deeper into like the changes needed on the scheduler and the kubelet side.
So have you decided which path we're gonna go? If not, what is the criteria? Like, are you gonna experiment with different things, run benchmarks to pick the right approach? So not maybe I missed that or not clear to me.
Like if you mean if we want to go with the unified model or the mixed model, I think like based on the discussion that has been happening on this doc, it it feels like it's more feasible to start with the mixed approach just because of the cost for implementing all of the changes on the DRA side. So and also like considering all of the scalability concerns. So yeah, the current proposal is with the assumption that like we are going ahead with the mixed approach for resource allocation.
Kevin.
Okay.
Yeah, I guess one thing I'm wondering, so for the CPU driver, is this driver going to be agnostic to like CPU vendors, and like with AMD and Intel and others, we'll be able to reuse this driver? And
Mhm.
yeah, because like I'm just wondering, like there seems to be a lot of vendor specific things that can permeate here, and I'm not exactly sure what how that will be handled with this.
I can try and answer like the current version or the current implementation of the CPU DRA driver is not very vendor specific. It mostly publishes and so on. But yeah, like if there are more things that can be vendor specific, that is something that I mean we can have like multiple DRA drivers which can publish the CPU resource claim. So it should be possible to do that, but the current driver doesn't do that.
I
Sasha?
see, yeah, Sasha's hand that's up.
Yeah, just to expand a bit about vendor-specific drivers. So we do expect what it will be vendor-specific drivers because like the logic and publish it attributes what, like for example, we are doing for Intel processors will be different a bit from what will be optimal for AMD processor or ARM processors in a sense. So current CPU driver, what Praveen is maintaining publicly, it's minimal implementation just to be comparable with what Kubernetes is currently doing. But for more advanced logic, definitely it will be more drivers. Another comment what I wanted to make, we discussed that with Praveen. So think about this proposal not only in the scope of consuming CPU resources per se. Think about that as additional attributes what can be consumed by the accelerator. Like our example from, let's say, like FPGA devices. So once you allocate FPGA device, you also need to have a huge pages, which is also native resource. So every time you get the device, you need to pre-allocate the huge page or set of huge pages. For us, it was such what we constantly saying to the users, what, hey, your pod is failing because you forgot to add it. So extending this API of specifying of native resources as attributes or linked attributes to the device allows us to improve the user experience of such devices. So when we can say what whoever consume this DRA XYZ, it will also get X amount of native resources. Would it be like CPU core, memory, huge pages, or whatever is needed? So think about, like, when you will be reviewing this document, think about it not only in the scope of CPU. It's anything what might be consumed when you are allocating accelerated devices.
Francesco.
Hello. So I want to just to comment on the following on the topic Kevin started, which is another point which will be need to address it is, okay, we can and hopefully, I guess, have drivers for different vendors, but the way they will expose the resources should be compatible somehow. Otherwise, if CPU foo exposes in such a way and CPU bar exposes in a different way, it becomes interesting to consume them. So this is probably too early to be a concern now, but I think that will be a concern someday. And probably my recommendation, my thought will be, okay, let's keep that in mind that down the road we'll probably have to deal with that.
Well, Francesca, if you want to have answer for that, we definitely seen the ways what different workloads want to see allocation in different variants. So, for example, like AI workloads, we want to have like full cores without hyperthreading disabled and so on and so forth. So it might be what like the full power of DRA with partitionable resources with composing, like way how we expose a set of shared resources and what kind of additional attributes we can give it to it. It will be workload specific allocations or exposure variants of it. Anyway.
I don't want to talk too much, but I just want to say that, I mean, the engineering me is happy, but out of experience, such freedom could be daunting because a comment I already hear a lot is, hey, there are too many knobs and too many moving parts. So, don't shoot the messenger, but this is what I'm hearing. So, I see why you say so and why it's desirable, but making it consumable, I don't know. I think we deserve some discussion, I believe.
Yeah, I think like in the current implementation, we have a couple of ways to expose the CPUs. One is like which exposes the granular information where each CPU is a device. The other way that I'm currently exploring is to use consumable capacity, which can kind of bucketize the CPUs within the node into like per node or like per cache pool and so on, and use that for like publishing the resource list. So, and that is kind of configurable through a flag for the CPU DRA driver daemon set. But yeah, like with consumable and partitionable devices, there could be like potentially more ways to model the CPU itself. Kevin?
Yeah, I guess the other thing, so what I see, at least looking at all these caps, there's a lot of interest in making, Kubernetes more dynamic, whether it's like resizing CPUs or memory or node resources. One thing I'm curious here is like DRA's story around mutable resources isn't the best, and this is kind of, I mean, it sounds like for exclusive, sorry, I forget the term. I think for exclusive CPUs, we didn't really allow resizing of resources, but I believe that is changing. And then I'm kind of curious, like, what do you think is that in scope in the future to kind of have more resizing of CPU resources with the DRA driver?
Yeah, I think like that's a good question. Currently, we are it's not in the scope like of this cap or something that we are working on. But yeah, since we are enabling like exclusive CPUs to be resized in kubelet, like with static CPU policy, this is something that we should uh, like potentially explore. But yeah, right now it's not being considered. I think Sasha.
Yeah, it's again to add a bit more to answer for Kevin. Yes, the whole story for devices inside containers, it doesn't really support nicely the dynamic updating of the things. So the whole DRA story of dynamically changing the claim and potentially scheduling and so on, it's out of scope. However, some portion of in-place vertical scaling for native resources still can be potentially usable. So through DRA driver, the workload can get the exclusive cores and make sure what like those are like always available, nothing changes, and like during the whole life cycle of a pod. But when we can do dynamic update based on what natively specified inside the pod spec for container. For those, it will be something what is allocated from shared pools, and application should be able to react to it, because like even in case if we forget completely about the DRA, when orchestration layer changes the CPU set for the container should be able to detect it and react to it, and its application should be designed to it. So the whole like side discussion what we had about in-place vertical scaling for CPU manager and so on, the application in any case need to distinguish what was allocated from the start and what is promised to be kind of immutable, and anything else which was scaled up or down. This is dynamic portion, and application needs to be ready what like kernel will change affinity of a process inside the container at any moment of time.
But this is already done even without in-place pod vertical scaling, because if you have a container, let's say that it doesn't use exclusive CPUs, and it uses default CPU, and then you add another pod which uses exclusive, then the default will already be changed.
Yeah, usually those scenarios is handled nicely by kernel, because application doesn't expect what those cores, or some of those cores are unchangeable. It's more my comment was more about the previously implicit rule. What if you have static policy enabled, and if you have guaranteed pod, your CPU set is always exactly that value and nothing changes. So some of applications were built well, hard-coded to this assumption. Most application doesn't care about that, but some application in the wild already hard-coded to that behavior.
Okay, yes, I agree.
Yeah, I think to jump in, I've done a bunch with resizing, so context, just to provide context. I've spent the last 2 years doing resizing of various sizes. I think there's a huge difference between the hardware specification of the node and the resources that you want to have it allow available to people. So I think it's very hard to couple those. Hot plug and I shouldn't say that. Hot plug is relatively straightforward. Hot unplug is extremely non-trivial. Right, but you can add and remove abstract resources much more simply. So, I don't think we necessarily need to assume that the mechanisms that provide kind of deeper scope into the guts of the hardware, which is very complex and becomes very nonlinear. Right, it's not like NUMA node A is not the same as NUMA node B, and it's not the same as something on PCI bus A and B. Right, dynamically changing those things is hard. And I'm not, so I'm not sure that we want to necessarily couple those two different things to one another. Whereas, a lot of pods just need CPU or just need RAM. If you just need CPU or RAM, if you're not interested in which NUMA node it's aligned on, what the cache profile is, then resizing becomes much simpler. So, I think it's definitely worth considering. We should make sure we're not painting ourselves into a corner, but I think it becomes very complicated very fast if you assume very detailed knowledge of the hardware, and you also assume that it's dynamic. And like was mentioned, the biggest problem, as I've been diving in this, is not us at all. It's that applications and plugins and Linux and all of these things above us really don't like it when you start mucking with their CPUs. We tried mucking with the CPU and immediately found like 5 different applications. One was in the kernel, one was out of the kernel, one was in the guest, one was in the hood, a whole bunch of different things that all, didn't work. And also amusingly had a bunch of comments on that, many of them saying, yeah, this doesn't work. We know it doesn't work, but we don't care because we're not handling this case. So anyway, I'm rambling a little bit now, but I think it's worth considering, but I don't necessarily think we should assume that the mechanisms for adding and removing resources are the same as the ones for kind of getting deep into the hardware. I don't know who the initial question was from, so you're welcome to push back on that, because I may be completely misrepresenting.
I'll also say we are a little bit past time, but it's a pretty good discussion. I don't know if anyone had any other quick items to note, but
I just want to say that timing box of the item actually really works today, at least to me. Thank you.
Yeah, great. I'm glad that it was helpful. Yeah. Awesome. Thank you, everyone, for a very productive meeting. And we'll see you next week. Thank you, everyone.
Thank you.
Thank you. Bye.
Thanks, folks. Bye.